Have you ever wondered what secrets the universe holds beyond what your eyes can see? The universe in its infinite expanse is like an unending book, each page filled with mysteries waiting to be unraveled. Stars, galaxies, nebulae, all these celestial bodies form a cosmic tapestry that is breathtakingly beautiful. But our visual perception of the universe, stunning as it is, only touches the surface. The universe is not just what meets the eye. It's a symphony of signals, a ballet of cosmic energy, a lot of which is invisible to the naked eye. The limitations of visual astronomy have long been recognized. There's a need for other methods, other tools to delve deeper, to explore the unseen spaces, the unheard stories of the universe. So, how do we go beyond? How do we unlock these secrets? How do we listen to the silent whispers of the cosmos? Enter radio astronomy, a tool that scientists use to explore the unseen universe. Radio astronomy, a relatively young field, took its first steps in the 1930s. The story of its birth is a fascinating one that begins with an engineer named Karl Jansky. Employed by Bell Telephone Laboratories, Jansky's initial task was to investigate sources of static that might interfere with radio telephone service. Little did he know, his work would lead him to uncover a whole new way of observing the universe. While trying to pinpoint the source of a persistent hiss-type static, Jansky made an unexpected discovery. He noticed that the static peaked once a day, but not every 24 hours, rather, every 23 hours and 56 minutes. This timing is not in sync with the Earth's rotation relative to the Sun, but with its rotation relative to the stars. Jansky realized that he was onto something big. The source of the static was not earthly, but cosmic. He had accidentally discovered cosmic radio waves, a form of light invisible to our eyes, but detectable by specially designed instruments. This was the birth of radio astronomy. The implications of Jansky's discovery were profound. For the first time, humanity had a tool to observe the universe beyond the limitations of visible light. It opened up a new window to the cosmos, allowing us to peer into regions of space obscured by dust and gas, and to detect objects that do not emit light in the visible spectrum. Following Jansky's discovery, the development of radio telescopes began. These are not your typical telescopes. Instead of a lens or mirror to gather light, radio telescopes use large, dish-like antennas to collect radio waves. The bigger the dish, the more sensitive the telescope, enabling it to detect fainter radio signals from distant cosmic sources. This was just the beginning, as radio astronomy started to unveil the universe's hidden secrets. Jansky's discovery was the spark that ignited a field that has since revolutionized our understanding of the universe. From black holes to cosmic microwave background radiation, radio astronomy continues to shed light on the darkest corners of the cosmos. And remember, it all started with a bit of static. With radio astronomy, scientists began to explore the universe beyond the visible spectrum. This pioneering field of science has allowed us to tap into the radio waves that are constantly streaming through space, providing us with a unique insight into the universe. So, how does radio astronomy work? Well, it all begins with a radio telescope. Unlike optical telescopes, which gather light, radio telescopes are designed to collect radio waves. These waves are a type of electromagnetic radiation, just like visible light, but they have much longer wavelengths. This means they can pass through dust and gas that would block visible light, allowing us to see parts of the universe that would otherwise be hidden. Once the radio waves are collected by the telescope, they are converted into an electrical signal. This signal is then amplified and processed by a computer, transforming it into an image or data that scientists can interpret. But what makes radio waves so special? Why not just stick with the light we can see? The answer lies in the unique information that radio waves can provide about celestial bodies. For instance, radio waves can reveal the presence of cold, dark objects in space that don't emit light. They can also detect the emissions from neutral hydrogen gas, the most abundant element in the universe. By mapping these emissions, astronomers can trace the structure and movement of galaxies. Radio waves can also penetrate through the dense dust clouds that surround newborn stars, giving us a glimpse into the early stages of stellar evolution. And they can even pick up the faint signals from pulsars, rapidly spinning neutron stars that serve as cosmic lighthouses, flashing their radio signals across the universe. From black holes to distant galaxies, radio astronomy has opened up new frontiers in space exploration. It's like being given a new set of eyes, allowing us to see the universe in a way that was once beyond our wildest dreams. So what has radio astronomy revealed about the universe? Well, let's dive into some of the major discoveries that have reshaped our understanding of the cosmos. First up, pulsars. These are rapidly rotating neutron stars that emit a beam of electromagnetic radiation. This radiation is only detectable when the beam points towards Earth, similar to the way a lighthouse beam sweeps across the ocean. The discovery of pulsars in the late 1960s was a triumph for radio astronomy. It opened up a new way of studying these extreme objects and the exotic physics that govern them. Pulsars have also been used as cosmic timekeepers due to their incredibly steady rotation. Next, we have quasars, the most luminous objects in the universe. These are supermassive black holes at the centers of distant galaxies, feasting on surrounding matter and spewing out jets of energetic particles. Radio astronomy unveiled these mysterious objects in the early 1960s. Quasars are so distant that their light takes billions of years to reach us, which means we're seeing them as they were when the universe was young. This allows us to study the early stages of galactic evolution. Then there's the discovery of the cosmic microwave background radiation, or CMB. This is the afterglow of the Big Bang, the event that sparked the birth of the universe. The CMB is a faint echo of the hot, dense state the universe was in just after the Big Bang, and it permeates all of space. Detected in the mid-1960s, this discovery solidified the Big Bang theory as the leading explanation for the origin of the universe. Finally, radio astronomy has provided evidence supporting the Big Bang theory itself. The universe is filled with a sea of hydrogen gas, and radio telescopes can detect the characteristic radio waves this gas emits. By studying how these waves have shifted over time, astronomers have been able to confirm that the universe is expanding. This expansion is a key prediction of the Big Bang theory, and its confirmation is one of the greatest achievements of radio astronomy. These discoveries, from pulsars and quasars to the cosmic microwave background radiation and evidence of the Big Bang, have fundamentally changed our view of the universe. They've shown us a cosmos that is vast and dynamic, filled with exotic objects and governed by extreme physics. They've allowed us to peer back in time to the universe's infancy, and they've confirmed our theories about its origins. But perhaps the most remarkable thing about these discoveries is how they were made. They weren't seen with the naked eye or even with a traditional optical telescope. No, these revelations about the universe came from studying the radio waves that permeate space. These discoveries have revolutionized our understanding of the universe, and they were all made possible by radio astronomy. As we continue to gaze into the cosmos, what does the future hold for radio astronomy? Just imagine the unexplored territories that lie beyond our current understanding, waiting to be discovered. With the advancements in technology, radio astronomy is set to unlock even more secrets of the universe. The potential for new discoveries is vast and mind-boggling, akin to a cosmic treasure hunt. The future of radio astronomy is brimming with exciting possibilities. As we refine our technology and methodologies, we'll be able to delve deeper into the cosmos, reaching farther and farther into the unknown. We'll get to know more about the formation of galaxies, the behavior of black holes, and the mysterious dark matter that constitutes a large portion of our universe. But what's even more exciting are the discoveries that we can't even anticipate. Those eureka moments where we stumble upon something completely unexpected, shattering our previous understanding and forcing us to rethink our place in the universe. There are numerous ongoing and planned projects that will significantly contribute to our knowledge of the cosmos. For instance, the Square Kilometre Array, an international endeavor, is set to become the world's largest radio telescope, with a total collecting area equivalent to 1 square kilometre. It aims to address fundamental questions about the universe, like how stars and galaxies form and what the nature of dark energy is. The future of radio astronomy is not just about new discoveries, it's also about inspiring the next generation of astronomers. Through outreach programs and educational initiatives, we can ignite a spark of curiosity in young minds, encouraging them to question, explore, and discover. As we continue our cosmic journey, we must remember that the universe is a vast, complex entity full of mysteries waiting to be unraveled. Our understanding of it is ever evolving, shaped by the tireless efforts of astronomers and the incredible technology at their disposal. With radio astronomy, the universe's mysteries are waiting to be discovered. So, next time you look up at the night sky, remember that there's more than meets the eye.